In this video, I will discuss some JEE Main PYQs from the topic Newton laws of motion. These questions have appeared between the years 2025 and 2023. Timestamps are given in the description box. You can watch parts of video if you are running short of time. This is the first question. A block of mass m is placed on a surface having vertical cross section given by y equal to x square by 4. If the coefficient of friction is 0.5, the maximum height above the ground at which the block can be placed without slipping is. You can pause and attempt this question. So the surface has got this profile. So this is y, this is x. So slope of this plane is like this. As you become more and more steep as you go higher. Here is less steep, here is more steep, here is more steep. For an inclined plane, say at an angle theta, when the mass is placed, so if the angle is too high, then the block will try to slip down. So the friction force will be upwards. So it's just about to slip. The downward force, which is mg sine theta, will be balanced by this friction force, which is mu to the normal reaction, which is mg cos theta. So from this we get tan theta equal to mu. So if mu is greater than, if theta is greater than tan inverse mu, then the block will start slipping. So here the theta value is constantly increasing. So at a particular value of theta, it will match with mu, and this theta for this given curve is dy by dx. The inclination of this tangent can be found by differentiating this one. So dy by dx of this curve will give the slope of this inclined plane, and that tan theta is dy by dx. And for this particular profile, dy by dx is 2x by 4. That should be equal to mu, which is 0.5. So half. So x equal to 1 meter. So when x is 1 meter, y will be 1 by 4 meter. So at a height of 1 by 4 meter from the ground, the slope will be high enough for the block to start slipping. Theta will reach a value so that it matches with the coefficient of friction mu. So the answer to this question is option A. A is the correct answer. So this would explain here for inclined plane. When it's just about slip, if theta is small, it will not slip. As we increase theta, that's the plane is becoming more and more steep. Then at certain value of theta, it will start slipping. Let this be the condition at which it's just about to slip. So here the downward force is the weight component mg sine theta. That should balance the upward friction force, which is mu in the normal reaction, with the maximum friction force because it's just about to slip. And the normal reaction is mg cos theta. From this you get tan theta equal to mu. So if theta is greater than the value of tan inverse mu, will start slipping. And tan theta for the curve profile that's given is dy by dx. And y is given as x square by 4. So derivative is 2x by 4. That should be equal to 0.5. So from this x equal to 1 meter, that corresponds to y equal to 1 by 4 meter. So at a height of 1 by 4 meter, the block will start slipping. This is the next question. As shown in figure, a 70 kg garden roller is pushed with a force 200 Newton at an angle 30 degrees with the horizontal. The normal reaction on the roller is. This is a simple question. So The forces acting on the solder are its weight, mg, because of gravity. Under this contact point, there will be a normal reaction, which will pass to the center. And this F will have two components, F cos 30 and F sin 30 downwards. So in the vertical direction, the normal reaction should balance the downward weight plus the downward component of this force. So the normal reaction N should be equal to the weight mg plus the F component, that is downwards, that is F sin 30. F cos 30 is horizontal, F sin 30 is vertical. Mass is given as 70, G is 10, force is 200 Newton, sin 30 is half. So 700 plus 100, 800. SI units Newton. C is the correct option. So this one explained here. The force is the weight and the normal action at the point of contact. It will pass to the center. So if you write the force balance about this point, normal action will be balanced by this downward force mg plus the F component, which is downwards. So from this, get the normal action as 800 Newton. Next question. A body of mass 1 kg is suspended with the help of two strings making angles as shown in the figure. Magnitude of tension T1 and T2 respectively are in Newton. Take acceleration due to gravity 10 meter per second square. So mass is there, weight is mg, two strings at these angles 30 and 60. So you have to find the values of T1 and T2. But pause and run this question. This was a simple question. We can use Lami's theorem. This straight line, so the total angle is 180. Here 60 plus 30 is 90. So the remaining angle, this is also 90 degrees. So Lami's theorem, the force T1 divided by the opposite angle, that's between this and this angle. Three forces T1, T2 and mg. So between T2 and mg, the angle is 90 plus 30. So T1 divided by sine 90 plus 30 equal to T2 divided by the angle opposite to that T2. T2 opposite is this one between T1 and this one. That's 90 plus 60 equal to mg by the angle opposite to that 90 degrees. So to find T1 and T2. So this is nothing but cos 30, which is root 3 by 2. And this is cos 60, which is half. Mass is 1 kg, G is 10. So the right hand side is equal to 10. So from this, tension 1 is 5 into root 3. Root 3 by 2, this one 5 root 3 Newton. And then second tension T2 is half of, so it's 5. T1 is 5 root 3, so option A. So the string which is vertical, this is more vertical compared to this one, this is more horizontal. So the vertical string should take more load. So T1 is 5 root 3 and T2 is 5. Option A is the correct answer. This is Lami's theorem. Three coplanar forces to be in equilibrium, T1 by the sine of the angle opposite to that force should be equal. So Lami's theorem, tension by the angle opposite to it, sine of the angle opposite to it, and T2 by sine of the angle opposite to it, plus the third force mg by the angle opposite to it, sine 90. And this mg is n is 1, g is 10, and sine 90 is 1. So T1 is 5 root 3, T2 is 5. The string which is more vertical take the more load. Next question. A body of mass m is suspended by two strings making angle theta 1 and theta 2. with horizontal ceiling with tangents T1 and T2 simultaneously. T1 and T2 are related as T1 equal to root 3 times T2. The angles theta1, theta2 are. 4 options are given. So here the figure is not given, so you have to draw the figure. So with the horizontal, it's making tension 1 is more, so string 1 should be more vertical. So one string is more vertical, second string is more horizontal. So this is T1 because the tension is more here. T1, this is T2, this is horizontal. So this angle is theta1, this angle theta2, mass same here. So weight will be downwards mg. So three forces are in equilibrium. So we can use Lami's theorem. So this is theta1. So if I draw a horizontal here, so this angle is also theta1, and this angle is theta2. Okay, so this is 180 minus theta1 plus theta2 because this straight line, the full angle is 180. So applying Lami's theorem, we can write T1 by this 90 degrees. It's similar to the previous question, sine 90 plus theta1, T2 by the sine of angle opposite to it, which is 90 plus theta1 t. So this should be theta2. Go to the third force mg. It will be angle opposite to mg is 180 minus theta1 plus theta2. So this is T1 by cos theta2 equal to T2 by, since it's 90, sine will become cos. And in the second quadrant, sine is positive, so it's plus, equal to mg by sine theta1 plus theta. Sine will remain sine because 180. In the second quadrant, sine is positive. So we can do out options from here. And T2 is being given as root 3 times T2. So T1 is more. So root 3 times 1 by cos theta2. So the two angles cannot be equal. Okay. And yeah, T1 by cos theta2. I made a mistake here. And this is theta1. So that means theta2 is 60 degrees. Theta2 is 30 degrees. Because cos 30 is root 3 by 1. Theta1 is 60 degrees. This is option C. A and B can be ruled out. And in that case, if you put theta1 plus theta2 equal to this one, you will get T2 as half mg. C is the correct option. This is what I explained here. So three forces T1, T2 and mg. And T1 is root 3 times T2. So T1 is more, so the string has to be more vertical. So Lami's theorem, T1 is sine angle of the angle opposite to T1, which is 90 plus theta2, and T2 by the angle opposite to it, which is 90 plus theta2, theta1, equal to mg by the angle opposite is 180 minus theta1 plus theta2. So you get root 3 as cos theta2 by cos theta1. So one possibility is theta2 is 30 degrees and theta1 is 60 degrees. So option C is the correct answer. And we can also get the value of T2 from using values of theta1 and theta2 as 60 and 30. Next question. In the given arrangement of a doubly inclined plane, two blocks of mass m and m are placed. The two blocks are connected by a light string passing over an ideal pulley as shown. The coefficient of friction between the surface and of the plane and the blocks is 0.25. The value of small m, for which m equal to 10 kg, will move on with an acceleration 2 meter per second square. Take g equal to 10, tan 37 is 3 by 4. You can pause on this question. So there is one shortcut way of solving this problem. We can assume the x-axis to be flexible along the string, and this is moving like this. So I'll take the x-axis to be like this. It's a flexible x-axis. It's possible because the string is flexible, and this is the positive direction of the x-axis. And I consider this block of m and m and the string as one system. So the forces acting in this positive x direction are mg sine 53 and mg sine 37 is in the negative x direction. So minus mg sine 37, and this friction force here is upwards. So it will oppose the motion. The friction force here is this way, following the negative x direction. So both the friction force are the negative x direction. So minus mu mg cos 53. Friction force mu in normal direction. Normal direction is mg cos theta minus mu mg cos 37. That is the net force in the positive x direction, which is equal to the total mass of the system, which is m plus m, into the acceleration u. So in this equation, everything is known except for the small m. So mg I can take commonly outside. Sine 53 is 4 by 5. For sine, as the angle increases, the value of sine will increase. Minus mu is half. Minus mg into sine 37 is 3 by 5 plus cos 37 mu into cos 37 equal to m plus m. The right answer m plus m into E is 2. Capital M is 10. Okay, so this we can simplify. So only m is unknown here. So right hand side we have 2m and mu is 0.25. So it's 1 by 4. Okay, so here this will become 20. So 4 times 16 minus 3 is 13. And then minus mg into this 4. So it will become 4 by 4. Right hand side is 10 plus m into 2. Okay, so if I collect m, it will be 2, and here g is 10. So 2 times, so 8 times. So 8 times small m plus 2m will become 10 times m, and capital M is 10 kg. So 10 and 10 will cancel. So 13 into 5 minus 20. So it's 45. Go to the right hand side. That means M is 4.5 SI units kg. Simple calculation. B is the correct answer. So this sort of explained here. So here I'm using this concept of flexible x-axis. The axis has become flexible because the string is flexible. So the I'll consider this M and M as a single system along with the strength. So the force along the positive x direction are this is a weight component downwards, which is mg sine 53, and the weight component downwards in the negative x direction is mg sine 37. So mg sine 53 minus mg sine 37. And then friction force is opposing the motion, so both will be negative. Mu into normal reaction, which is mg cos 53 and cos 37 for the small m, which equals the total mass of the system m plus m into the acceleration. So here everything is known except for the small mass. So mg sine 53, 4 by 5, and then here mu is 1 by 4, mg I have taken common outside, and cos 53 is 3 by 5. And then small m terms, which is mg sine 37, 3 by 5, and then mu is 1 by 4, cos 37 is 4 by 5. So this is 4 by 5, this is 13 by 20, and m plus m into plus 10 into 2. So collecting the small m terms, 2m plus this one, right side will become plus 8m, and capital M terms, 13 by 20, this is 10, 110 will cancel, g is also 10, so 13 into 5. So 2 times 10, it will come on the left side, will become minus 20. So from this I get m as 4.5 kg.